Hi, geometry class. I'm going to have you guys be doing 7.1 today for notes and homework. I will post these notes as a PDF also with this video, so if you want to just look back at the PDF of what's written down, you can do that also, and I'll also post a video where you guys can see it if you want to rewatch it. 7.1 is all about ratios. This should be review from your math classes before. What ratios are is when you have comparing two things, okay? A lot of times we might write it as the one number over the other one as a fraction, or sometimes you can write it as a colon with a colon in the middle, or you can write the word to, T-O, in the middle. But always remember to reduce the numbers as much as you can as you're working with it, which is probably why I tend to use the fraction version of it when we're doing it. We're going to look at some problems today where you have extended ratios. This includes, we're talking about the angles of a triangle where you're going to have three numbers that you're going to be comparing. We'll also do this with the sides of the triangles. Make sure when we're dealing with angles for a triangle, inside we're equaling to 180. When we're talking about the sides, then we're going to equal it to whatever the perimeter is. A proportion is when you have two fractions and you're comparing them as you're going through it. Okay, when we work with that, we're going to be cross multiplying a lot as we do this, where we have the two fractions and you go the one way, you multiply them together, equals going the other way. The biggest mistake that students see is they forget to put the equal sign in the middle between these, okay? Multiply the one way, equals multiplying the other way. Another warning I have for you is that when you're doing this, you cannot do cross multiplying if you have two fractions on one side. So let's say if you have x over 2 plus x again over 5 equals 7 over 20, let's say. Okay, you cannot cross multiply in this situation. Cross multiplying only works when it's simply two fractions with an equal sign in the middle. Here's a problem where they're talking about the students at a school. Okay, they have that we have 520 students that are enrolled in sports. They're the athletes. Okay, in the whole school we have 1,850. They want to look at the athlete to student ratio. Okay, all you do is you take the numbers. The one that they say first goes on top, the one that they say second goes on bottom, and here they want it to the nearest tenth, so you can just divide it out and get a decimal. Okay, I want to warn you to be careful. Sometimes they can ask you questions like, what is the ratio of athletes to non-athletes? Okay. Okay, to non-athletes as we're looking at this. Okay, if that's the case, well, I know I have 520 athletes in the school, but I need to take and do 1850. Oops. Got to try to clear out my calculator. Okay, so I'm doing 1850 minus the 520 that are athletes. That leaves me with 1330 for non-athletes. Okay, then I would reduce that. Okay, or I could divide it out if they simply want it as a tenth. Okay, if you're having to put it as a fraction, okay, especially if you're using the yellow calculators, if you have zeros, you can cancel them off. Okay, you can use the fraction button and it'll reduce it for you. Okay, here if I punch this in and I reduce it, it gives me 26 over 665 for a simplified fraction of it. Okay, another warning that I want to warn you about as you're doing this, okay, is that sometimes you might have fractions that have decimals in it. Okay, let's say, for example, they gave you 1.8 over 3. You can't type into a calculator with a decimal. It'll come out with a decimal. What you need to do is multiply everything by 10 in this case, because I want to move one spot. If I had two decimal places, I would multiply by 100. So I'd multiply 1.8 times 10 and it becomes 18. I multiply 3 times 10 and it becomes 30, and then I can reduce. If I reduce by 2, it's 9 over 15, but remember that's not as simple as it can go, because 3 would still go into that and we would have 3 over 5. Okay, make sure you reduce it all the way down as you're going through it. Okay. Here's where we get into the extended ratio, okay? They're giving me a triangle here, and they say the angles are in a ratio of 5 to 12 to 13. What that means is the actual amount that the angles are reduced down to 5, 12, and 13, okay? Maybe if they were just twice as big, it could have been 10, 120, and 130, okay? We need to figure out what factor it was that we reduced by to make it so it was just 5, 12, and 13. Because of that, you add an X to each spot in the corner as you're looking at your triangle, okay? Then you take and you add together 5x, 12x, and 13x. Since we're talking about angles here, the sum of the angles inside always equals 180. So this is going to be 180 here. Combine your x's, divide by 30 here, and I get x equals 6. So what we really had was that the angles, when I plug 6 back in, I get 30, 72, and 78. But 30, 72, and 78 are all reducible by 6. So when we say it as a ratio, we just said the 5, the 12, and the 13. So remember on these problems to add an x into each one of the ratio numbers that they give you. Then if it's angles, add it to equal 180. Okay. However, though, if I take the same problem and I change it so I do sides instead, okay, I still use the exact same numbers, okay. Notice in the problem here it said the perimeter is 90 centimeters. If I'm talking about angles, like we did a minute ago, that's completely useless. I don't need that. But if I'm talking about sides, then I need to set it equal to the perimeter. So here I have 5x plus 12x plus 13x to give me 90. Still get 30x, divide by 3, and this time x equals 3. Okay, so the sides were actually 15, 36, and 39. Here it's talking about cross multiplying and how you multiply the one way equals multiplying the other way. I'm sure you're fairly familiar with this. So here's an example. You multiply here, I multiply the 6 and the y. I get 6y. I multiply the 9, and that's an 18.2. The decimal's kind of covered up there, to get 163.8. Divide by 6, and I get my answer there. It gets a little bit more complicated, okay, actually a lot more complicated, a lot more chance that you're going to make a mistake when they put one of the terms, top or bottom, to be a binomial, where you have a number, plus or minus, and then another number here, okay? Whenever you do that, you need to make sure that you distribute the number that we have here times both terms here. So that's why I have the 6 written here like this. I would recommend that you write the number that you have, parentheses, the 2-term thing here, and then distribute through as you're working with it. Okay, from there you can then work it out, and you see here that we got -2. Here's another example with the number with it. Make sure you distribute it through, okay? The common thing that students will do is they'll take the 2 times the 7 here and just make it 14n, and then keep it -1. Don't forget to take the 2 times the 1 also, and make it a 2 there, okay? Here's a word problem now. There are multiple correct ways that you can set up the word problem. You just have to be consistent about how you set it up. Here, when I'm setting it up, I'm going to put the students who have pets on top and the total number of students on the bottom. We make one column for what it is in our survey that we're doing and another one for what it is in real life. Okay, so we did a survey. We've asked 30 students. So that's our total number of students for the survey, 30. It goes on the bottom here. Of that, 18 have a cat or a dog. So I put 18 up on top. I want to know how many kids in the school actually probably have a pet then, if that ratio is going to hold true. So I don't know how many students in the whole school have a pet, but I know there's 870 students in the whole school. So you set it up, cross multiply, divide, and we get an answer of 522 students. So be consistent about how you set it up. That's not the only way to set it up, but if I'm putting students who have pets on top, I want to do that both ways, okay? Here's another example, okay? When I have students do that, I let them set it up themselves. Here's one way that somebody set it up. 20 kids have a part-time job out of the 50 that were asked, okay? How many total kids in the school have a part-time job then? Out of the 810, and you can cross-multiply. Somebody else might have said, well, 20 students have a job out of, in real life, I don't know how many. So we're talking about who has jobs. This is a survey. Bottom is real life, okay? Top is survey, total number of people we have. Bottom is real life, total number of people we have. Either way, when you cross multiply, you're going to get the same answer of 324. which is why we have what we call equivalent proportions. There's more than one correct way to often set up proportions. As long as when you cross multiply, you're always going to get the same thing, then they're all equivalent. So for all these examples here that you look at on the bottom, okay, pay attention to the commas between. If I go the one way, I have 50 times x. If I go the other way, I have 28 times 755. So all of these are equivalent because the same things are across from each other when they cross multiply as you're working with this. Okay. Now, on your homework, we have a couple things. And in the past, we've gone over factoring right before we do Chapter 7. This year, we did factoring at the end of Chapter 0. So you are going to need to remember some of those things that we covered before. Okay. Remember when you have two terms like this, like you're going to have in problem number 31, you need to FOIL it together. Okay. Remember first, outer, inner, and then last. Okay. You're going to get a term here, okay, with x's, two numbers in the middle for your O and your I, and then your last. The O and the I can combine together. That's going to equal 18. You need to then move your 18 over so you have it equal to 0. Once you have that, you should be able to factor that apart in number 31, set them both equal to 0, and work on figuring out what x is. Okay. On number 32, here's a hint example for something you can do on number 32. If you have something like x squared minus 16, remember we studied that's a special factoring called a difference of perfect squares, where that breaks up into x plus 4 and x minus 4. Numbers are a little bit different, but you can use this concept as you do number 32. Okay. On number 33, it will not factor. You are going to have to do the quadratic formula. So if you don't know the quadratic formula, here's a place to look to write it down. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, good luck. Work on your 7.1 homework.